Hello and welcome to another video, this time doing the question 4 from the June 2018 stats paper, which is an A2 paper, and this is on what I describe this topic as sampling, statistical diagrams and measures. Basically it's where you've got the mean, mode, median stuff, maybe some diagrams, and as this one has, maybe some questions about sampling. Okay, so let's have a look. Now the start of this question is about non-random sampling, and there's only two non-random sampling methods that you're required to know about in A-level, and those are the type of sampling they're describing here, which is probably the weakest type of sampling, as in the one where you just literally sample people as and when they turn up at a particular place, where there's all kinds of bias which might be in there, but sometimes we need to use this type of sampling. Now this is called opportunity sampling. That's the way the book describes it. Sometimes it's referred to as convenient sampling as well, because it is just convenient, yeah? And that's because Charlie's not taking any effort to do anything random, yeah, definitely not. He just stands at the door between these particular times and asks workers as they arrive how long their journey was. You can see as well here why, you don't necessarily desperately need a random sample. You can see why he's doing this, and it seems like a sensible way of doing the sampling, but it's a non-random sample, and so it's not going to be, if you like, as fair as conducting a random sample. But yeah, that's opportunity sampling. Okay, state and briefly describe an alternative method of non-random sampling that Charlie could have used to obtain his sample of 40 workers. Well, the only other type of non-random sampling is quota sampling. Yeah, and quota sampling is different from opportunity sampling in that you have to fulfill a quota. It's much more like stratified sampling, but it isn't the same as stratified sampling, because in stratified sampling there is a form of randomness, because what you tend to do with your strata is still select them in some way randomly from the population. That's the idea anyway, so that's why stratified sampling is a form of random sampling. Quota sampling though is not, so they want quota sampling, and we've got to briefly describe how he could have done that. So he could have made sure, for example, that he selected the same proportion of men and women at work as are in the whole of the office in the original population. That's probably what I would do. So I'd say something like let's make sure Charlie selects the correct proportions of men and women, which may well be 50-50, but may well not be 50-50, depending on how many men and women are in his work. So let's make sure Charlie selects, sorry, I've missed the word select, the correct proportion of men and women because it might be the case that men take longer or shorter to get to work. They might have different length journeys from the original population. And you can always give an example. For example, if 70% are men or women, let's say 70% are women, Charlie needs to select what's 70% of 40. It is 28. As they arrive. And obviously with quota sampling, once you've reached a quota, you don't have to ask any more of those. So yeah, they just want a brief description of how the system might work. Yeah, so that seems like the the easiest way of doing it. Remember, it's non-random, so we just literally pick them as they arrive, because those two types of sampling are non-random. Okay, Daruni decided to ask every member of the company the time X minute it takes them to travel to the office. State the data selection process that Daruni used. Okay, she's asking every member of the company the time X minutes it takes them to travel to the office. This key word here is every member of the company, isn't it? If you ask every member of the company, then that's a census. Yeah. So as we can see, this is very much about sampling these first 4 marks, and sampling isn't difficult, but it is easy to get wrong. And that's just because it's the kind of chapter which you rush through very quickly and never sort of return to again. It's all in chapter 1 of the AS textbook, chapter 1 of the AS textbook. It's all there. Okay, Daruni's results are summarised in a box plot below, and the summary statistics are here as well. Okay, so we've got that, and we've also got this. Okay, write down the interquartile range for these data? Well, that's just going to be 58, because that's the upper quartile, minus 26, and so that sounds to me like 32. And as this was in minutes, that will be in minutes as well. That's the interquartile range, 32 minutes. Calculate the mean and standard deviation. Well, here's where you see that you do need to know the formulas, yeah? Because here, there's nothing to type into your calculator. You're going to need to use a formula. Most of the time, the questions do give you the original data, and you can just plug it into your calculator, but this isn't one of those times. So let's just quickly note down that the mean is going to be the sum of x over n, and in this case, that is 4133 over 95, and you can just work that out as 43.5 to three significant figures. And then the standard deviation, that's more complicated. You've got to do the square root of, that's the mean of the squares minus the square of the mean. That's how I remember that formula, but it is in the formula book, that. And so you've got the square root of, make sure you know where it is in the formula book though, don't take my word for it, have a good look at it, because it can look quite different sometimes. Okay, 202,294 over, if I put 2 there, sorry, that's a mistake, that should be an n, apologies, and so that's going to be over 95, minus 4133 over 95 all squared. Yeah, always check your working, it's something I don't do enough of in many ways, but that should come to 15.4 minutes. Yeah, and these are in minutes as well, just like the interquartile range is in minutes. Cool, done. State, giving a reason, whether you recommend using the mean and standard deviation or the median and interquartile range to describe these data. Well, this kind of question, it has a very simple kind of approach. If you always just remember this, that basically if there's outliers, the median is better. Yeah, if there's outliers or skew, actually, the median and the interquartile range are better. Now let's talk about why. So as the data has outliers, we can see it's got outliers because of these two. As the data has outliers, I would prefer to use the median and interquartile range, as they are more resistant to the effects of outliers. I would prefer to use the median and IQR, since the mean and standard deviation are more easily swayed by outliers. That's the key thing here. That's what they're looking for. So as the mean and standard deviation are more affected let's put it like this, are more affected by rogue pieces of data. Let's call them rogue pieces of data, or just by just one piece of data, by just one or two extreme items of data. And we can see these on the box plot, and we can see there are outliers on the box plot. And that's it, that's all you need. Okay, right, very last question now. Rana and David both work for a company and have moved house since Taruni collected her data. Okay, Rana's journey to work has changed from 75 to 35, so that's gone down by 40. And Dave's journey has changed from 60 to 33, so that's gone down by 27. Yeah. Now, she drew a box plot again, and she only had to change 2 values. That's interesting. She only had to change 2. Now, if we look, the highest item of data was 92, and the lowest was 20. So I don't think either of these are going to be, affecting those. Yeah. Explain which 2 values Taruni must have changed and whether each of these values increased or decreased. Well, it looks like certainly that the outliers aren't going to change because they're right the way up here. It doesn't look like the extreme items of data are going to change either. And so if this has gone from 75 to 35, I would suggest that the upper quartile is definitely going to change. And what's more, if the upper quartile, and basically got to think about where, where his data has have lied in here, yeah. So Q3 upper quartile will decrease since both values were, and if you look, because the upper quartile was before at 58, this 75 and this 60 were both above the upper quartile, if you see what I mean, and they're now below the upper quartile. So, we need to move that upper quartile lower. Upper quartile will decrease since both values were above the upper quartile, were originally above the upper quartile. And now they're below. Do you see what I mean? So that must reduce the upper quartile. Okay, cool. And it's also the median which will change. Q2 will also decrease since both values are now smaller than the median. Since both values are now smaller than the previous median. Yeah, that must have the effect of bringing the median down. Nothing else will change though. They can be quite hard, those kinds of questions. Sometimes you really do have to think, and that should get you the mark. I'm just going to quickly check I'm right there. Yep, both Q2 and Q3 will be lower, and it's about the fact that they were both above the upper quartile and they moved to lower than the median. Do you see what I mean? Like they were both here, then they moved down here, so that value and that value need to move down. And that's a sampling question. You can see why students get stressed at these kinds of things, although it's not that bad. We didn't really do that much real maths, I would say there. It's more just like being very aware of how sampling works and about the 5 types of sampling. 3 random sampling styles, so simple random sampling, stratified sampling, and systematic sampling. Those are the types of random sampling, and then you've got a non-random sampling, opportunity sampling and quota sampling. Know what a census is, know what outliers are, and know the formulas. That's all that question's about. Okay, hope you enjoyed the video. Keep up the hard work. Bye bye.